Next, I want to talk about missing values in R. Capital N, capital A represents a missing value. Here I've created a vector by combining 1, 2, NA, and 4. And this is a numeric vector, but only 3 of its values are actual numbers. The first, the second, and the fourth. The third value is a missing value. Arithmetic with missing values gives missing results. So 1 plus 1 is 2, but 1 plus NA is NA. NA is a placeholder for a value that you're claiming not to know. And so, of course, if you ask what 1 plus something is where you don't know the something, R will tell you that it doesn't know the answer. Most real data that we work with has some missing values in it. To illustrate, I'm going to set some missing values in our example data frame. So here's the negotiation study data frame as we read it from the CSV file. I'm going to use square brackets with the confidence vector from the negotiation study data frame and the assignment operator to change the 26th value of the confidence vector in that data frame to NA. I'm also going to change the 27th value of the salary vector to NA. Here's the new negotiation study data frame, and we can see that those two values have been changed from their original numbers to NA. So now confidence and salary each have one missing value in them. Basic descriptive functions, like mean and sum and standard deviation, act like arithmetic by default. So if I ask for the sum of salary, now I get NA instead of the sum of all of the observed salaries in the dataset. And this makes sense because one of the salaries is unknown, so the sum of all the salaries is also unknown. And if I ask for the mean of the salary, I also get NA. Sometimes, perhaps even most of the time, we want to exclude missing values before calculating basic descriptive statistics like this. To do so, we use the na.rm argument to those descriptive functions. So if I call the sum function with the argument negotiation study $salary, but I supply an extra argument, na.rm, and give it the value true, then I get the sum of all the values that are not missing. T, remember, is shorthand for true, and it's very handy for supplying arguments to functions like this. When I call the mean function with na.rm equals true, I get the mean of all of the non-missing values in the dataset. Many functions have options that you can set using special arguments that take true and false as their input values. The is.na function is useful for identifying missing values. Is.na of 3 gives false because 3 is not a missing value, but is.na of na gives true. You would only rarely want to use this function with a single input value, but it's very handy with vectors. Is.na of salary gives a vector of trues and falses where the trues correspond to those salaries that have missing values. In this case, there's only one true. And if I call the table function on the result of is.na of salary, I will learn that there are 31 falses and 1 true. In other words, one of the salary values is missing and 31 of them are not missing. By the way, you can plug the output of one function directly into another function, like I've done here. Is.na of negotiation study salary outputs a logical vector, a vector of trues and falses, and we saw that vector a second ago. So table of is.na of negotiation study $salary outputs a table of that vector of trues and falses. Functions like lm exclude missing values by default. So if I call the lm function on the formula salary tilde confidence, with confidence as the predictor and salary as the response, the sample size for this regression model is only 30, not 32, because we made it so that row 26 has a missing value for confidence and row 27 has a missing value for salary. So both of those rows cannot be used in this regression model. In this case, I plugged the output of the lm function directly into the summary function in order to get this descriptive summary table right away. Next, I want to talk about computing composite scores. And for this purpose, I'm going to read in the other example CSV file that I shared with you. This file has hypothetical responses to Big 5 inventory items about extroversion. Here is a representation of that entire data frame. We can see that there are several extroversion items as the columns, and also a variable representing age of the participant. The cbind function can turn vectors into columns of a matrix. So if I have a vector called x, that's 1, 2, 3, a short numeric vector, and a vector called y, that's 4, 5, 6, I can call cbind with two arguments, x and y, and it will create a matrix with two columns that represent the values of x and the values of y. This is handy because it allows us to collect a set of items that we want to work with temporarily in a matrix so that we can do things with that matrix. I'm going to create a temporary matrix of the extroversion items from the dataset. I'm going to do so by running this rather long line of code. I've called cbind with separate arguments for each individual vector retrieved from the extroversion study data frame representing an item for extroversion. Each of these lines ends with a comma. The function call is not done, so R is waiting for me to finish the line of code, even though it's printed across multiple lines of my text file. When I finish the last line with the last two extroversion items in the closed parenthesis for cbind, what I get is a matrix with 8 columns representing the 8 items on the extroversion scale. But that was kind of annoying to type, so here's a shorter way to do it using the with function. This line of code that I'm about to complete began with the function with. With is a function that takes 2 arguments. The first argument is the data that you want to use, and the second argument is the thing that you actually want to do with that data. In this case, the cbind function with all of the arguments that I want, except that I can give those arguments without repeating extroversion study $ for each one. With says, for the next step, get all the variables from this one data frame called extroversion study. And now here is that step. Cbind together, talkative, reserved, energetic, and so forth. The result of that with function call is the same matrix with 8 columns representing the items on the extroversion scale. But actually, I need to reverse score 3 of those items. This version of the function call to with cbind as its second argument has 8 minus reserved, 8 minus quiet, and 8 minus shy in place of reserved, quiet, and shy. This is not a problem because we can do basic arithmetic with vectors. Reserved, quiet, and shy are vectors that are stored in the extroversion study data frame, and because I'm calling with, R knows where to find those 3 vectors without me explicitly saying extroversion study $ before each one of them. And doing 8 minus a value, that's a rating scale from 1 to 7, gives the reverse scored version of that value, because 7 will become 1, 6 will become 2, and so forth. So here's the same matrix with 8 columns representing the 8 items on the extroversion scale, except that 3 of them have been reverse scored. Now we've lost the names of those 3 items, but that's okay. We're not going to keep this matrix for long. Here I've run a line of code that stores that matrix for a moment with a name extroversion items. Here I only intend extroversion items as a temporary name for the matrix that I know results from this entire function call with extroversion study, cbind together these 8 columns with some arithmetic done to some of them. What I'm going to do with that matrix is calculate the means of its rows using the row means function. So now that extroversion items is a matrix where all of the columns represent items on the extroversion scale, with higher scores indicating more extroversion, I can calculate the row means of that matrix, and those row means will represent the scale scores for extroversion for each of the participants in the sample. Now that we know how to calculate row means of a matrix in this way, we can use it to add a vector of composite scores to the extroversion study data frame. I'm using the $ operator with the assignment operator to create a new variable, extroversion, within the extroversion study data frame. And the thing that I'm assigning to that new variable is the row means of the extroversion items matrix, which is the extroversion score for each participant in order from 1 to 32. Most of the time, I would do it in one step instead of building it up piece by piece the way I showed you. This is that step. I took the extroversion study data frame and a new column, extroversion, and I assigned to that new column the result of calling row means on the matrix that I get by calling with extroversion study as the first argument, indicating that everything in cbind is going to come from extroversion study. And the second argument to with is cbind and specifies the 8 columns that I want to combine in a matrix, with 3 of them being reverse scored like this. And then I end the cbind function, end the with function, and end the row means function. And all of this together creates extroversion scale scores corresponding to each individual participant in the extroversion study data frame. Here's what that data frame looks like now. It has a new column called extroversion that has the mean scale scores for extroversion for each of the participants. Next, I want to talk about packages. There are nearly 20,000 packages on the comprehensive R archive network. You will be able to use all sorts of cool functions from various packages. For now, I just want to show you the standard way of loading a package that you have installed. I'm focusing on this one function in the car package, recode, just for the sake of example. So there is a function in the package called car that's named recode, but no such function is currently available in R. If I try to print the value of recode to the console, all I get is error object recode not found. You can only load a package if it's already installed on your system. There are several ways to install a package. For example, if you wanted to install the car package, if you were using RGUI, then you could go to Packages, Install Packages. If you're using RStudio, you could go to Tools, Install Packages. Or you could just run the line of code below without the comment character. Install.packages with car as a string as its argument. This will figure out the default way of installing packages on your platform, find the car package in the comprehensive R archive network, and attempt to install it. I don't need to run this line of code right now because the car package is already installed on my system. You only need to do this once for a given package. You don't need to do it every time you use the package. To actually use the car package, the key function I'm going to call is library. Given that car is already installed on my system, I can call library with the argument car, and I don't need quotation marks in this case, although I can use them if I want. What it will do is load all the functions and variables available in that package into the current R session so that I can use them. Now the function recode is available for use. For example, I could print the entire function to the console, although I probably wouldn't really want to do that. But the point is that I don't get error object recode not found anymore. To give a quick illustration of how to use the recode function, first recall that negotiation study data frame has a vector called race in it with 3 unique values, Asian, Black, and White, where 12 of the participants evaluated an Asian job applicant, 10 a Black job applicant, and 10 a White job applicant. I can call the recode function with the first argument being a vector that I want to recode, and the second argument being a long character string that gives instructions for how to recode that vector in a specific format demanded by this function. I want the string Asian to become just the letter A semicolon indicates that I'm moving on to the next instruction. The string Black should become just B, and the string White should become just W. All of these instructions are included in this larger string, which I'm using double quotes for. These single quotes on the inside are a way of indicating quotation marks within a longer string. I've taken the output of the recode function and assigned it to a new vector within negotiation study, which I'm calling race_short. And if I call the table function on that new vector, I can see that I now have a shortened version of the race variable that has labels A, B, and W instead of spelling out Asian, Black, and White. This recode function is not that important. I'm just using it as an example of a function that you can get from the car package, because I wanted to illustrate why you would load a package in order to get access to a function that you otherwise wouldn't have access to. Later, we'll make heavy use of the ANOVA function from the car package, but that function is far too complex for it to be worth using for a simple example like this.